Right, next one is alternating series. Right, in the previous classes already we discussed the so many tests to find out the nature of positive series. What are those tests? Ratio test, then auxiliary series pretest, geometric test, then limit form of comparison test, then Cauchy's integral test and nth root test. Now in this class I am going to explain the alternating series and the test to check the nature of the series of alternating series. Right? Alternating series means the series whose terms are alternatively positive and negative signs. That is, if one is positive, the second one is negative sign, and third one is positive, fourth one is negative sign. Means that if alternatively the signs changes, that series is called alternating series. Right? So what is this form? U1 minus U2 plus U3 minus U4 and so on plus minus 1 power n minus 1 into Un. If the series is in this form, then the series is called alternating series. But here the signs are different. If you observe here, U1, U2, U3 and so on, Un all are positive only. So we have to write the signs before the terms of Un, one time plus, other time minus. But very important thing is, all these terms are positive terms only, right? In between the terms, one time we are writing plus, another time we are writing minus. So only one test available, which is Lebanese test or Lebanese theorem to check the nature of alternating series. See, the alternating series sigma n equal to 0 to infinity minus 1 to the power n minus 1 Un. This is the alternating series form. If it satisfies two conditions, what are those two conditions? First condition is U1 greater than or equal to U2 greater than or equal to so on greater than Un greater than or equal to Un plus 1. Means that the terms of the series gradually decreasing, otherwise non-increasing terms, right? Second condition is limit n tends to infinity Un is equal to 0. If any alternating series satisfies these two conditions, then that alternating series is convergent. If any one of the two conditions, otherwise both the conditions fail, then the alternating series is not convergent, then we say that it is divergent, right? So here the second one is, if we apply the limit as n tends to infinity, Un must be equal to 0. The first one is always the term is greater than its succeeding term, right? So now see the problems on this one. First problem is test for convergence of 1 minus 1 by 2 plus 1 by 4 minus 1 by 8 and so on. First we have to write down its generalized form. First term is 1, second term is 1 by 2. Leave the signs before the terms. To represent those alternative signs, we have to mention this minus 1 to the power n minus 1, right? So third one is 1 by 4, fourth one is 1 by 8. So which can be written as 1 by 4 means 1 by 2 square, 1 by 8 means 1 by 2 cube. Now can we generalize what is the nth term? 1 by 2 to the power n, right? So given series can be written as, because the nth term is 1 by 2 to the power n, we can write it as summation 1 by 2 power n. To represent these alternative signs, we have to note down minus 1 power n minus 1. N is equal to 1 to infinity, right? N is equal to 1 to infinity by leaving the first term. Otherwise, take this minus 1 by leaving the Because the first term is 1 here. When we get 1 by 2 power 0. Right? So already you know the nature of the series does not alter if we add, otherwise subtract some finite value from the series. Because 1 is a finite value, after finding the nature of the series, if we add that finite number 1 to that series, nature does not alter, right? So what is un here? Un is equal to 1 by 2 power n, right? So to check the first condition, the easy task is here un greater than un plus 1, right? So we can write it as un greater than un plus 1. In other words, un minus un plus 1 greater than 0. So what is the easy task? We have to consider un minus un plus 1. If it is more than 0, then our condition satisfies. If it is less than 0, first condition fails. Right? So from this one, un plus 1 is 1 by 2 to the power n plus 1. So first condition, consider un minus un plus 1, which is equal to 1 by 2 power n minus 1 by 2 power n plus 1. Taking common 1 by 2 power n, remaining is 1 minus half. It is 1 by 2 power n into 1 by 2, which is 1 by 2 power n plus 1. Here n starts with 1, that means it is a positive number. 2 power n plus 1 is also positive. 1 by positive value is positive. Clearly it is greater than 0. Therefore, un minus un plus 1 greater than 0 for each n implies un greater than un plus 1 for every n. So first condition satisfies. What about the second condition? Second condition is limit n tends to infinity, un is equal to 0. Now consider limit n tends to infinity un, which is equal to limit n tends to infinity. What is un? 1 by 2 power n. As n tends to infinity, 2 power infinity is infinity, 1 by infinity is 0. So second condition also satisfies. Therefore, by Leibniz test, given series is convergent. Okay. But this is the way how to check the nature of the alternating series. Now we will see the second problem. Test for convergence of this series because the signs are alternatively changes, so that given series is alternating series. Given series is alternating series. Now we have to write down its generalized form. So what is the first term? First term is 1 by 6. Second term is 2 by 11. Third term is 3 by 16. Fourth term is 4 by 21. If we observe first the numerators 1, 2, 3, 4, they are moving parallelly according to the numbers. So what is the nth term? Numerator is n. Just now you compare the denominator term. If it is 1, it is 6. 6 is more than 5 compared to this 1. If it is 2, it is 11. 2 into 5 plus 1. If it is 16, 3 into 5 plus 1. If it is n, how can we write the nth term? It is 2 into, so 5 into 1 plus 1. 5 into 2 plus 1. So 5 into n plus 1. Right? 5 times this number. Then we have to add 1 to that one. So the generalized form is, given series is summation 1n by 5n plus 1, because to mention these alternative signs plus and minus, we write minus 1 to the power n minus 1, n is equal to 1 to infinity, right? So what is the nth term here? While we apply the Lebanese test, nth term un means the term beside sigma and also including minus 1 power n minus 1. Right, here nth term un is equal to n by 5n plus 1. To check the first condition, that is un1 greater than u2 greater than and so on, un greater than un plus 1, terms are decreasing gradually. Instead of checking everyone, it is enough to check un greater than un plus 1. We can write this in other way, un minus un plus 1 greater than 0. Right? So that consider un minus un plus 1. Un is n by 5n plus 1. Un plus 1. How can we write un plus 1? Put n is equal to n plus 1 here. So n plus 1 by 5 into n plus 1 plus 1 is equal to, apply the LCM, n into 5n plus 5 plus 1 minus of n plus 1 into 5n plus 1 by 5n plus 1 into 5n plus 6. This is the second term value, right? So which is equal to 5n square plus 5n plus n. Multiply these two values, right? So 5n into n is 5n square plus n plus 5n, total it becomes 6n, before negative sign minus 6n, 1 into 1 is 1, before sign is negative minus 1, whole by 5n plus 1 into 5n plus 6, right? So 5n square gets cancelled. Now what is remaining? 5n plus n, 6n, together cancel with this one, minus 6n, right? So what is remaining? Minus 1 by 5n plus 1 into 5n plus 6. Continuing here, right? So minus 1 by 5n plus 1 into 5n plus 6. If you observe this summation, sigma always n starts with 1. That means all the values of n are positive only. So you will get 5n plus 1 and 5n plus 6. Both are positive in the denominator. Now coming to the numerator, its value is minus 1. Minus 1 means numerator is negative, denominator is positive. So total value is negative, which is less than 0. If it is less than 0, we can write un minus un plus 1 is less than 0, implies un less than un plus 1, right? Un less than un plus 1. That means our first condition fails. First condition fails. So by Lebanese test, given series is divergent, right? So if any one of the two conditions fails, then the given series is divergent. Otherwise, if both conditions fails, then the given series is divergent. In this problem too, the first condition itself fails, so no need to check the second condition. Directly we can write it as given series is not convergent, otherwise it is divergent, right? Right, next sum, test for convergence of the series x by 1 plus x minus x square by 1 plus x square plus x cube by 1 plus x cube minus x to the power 4 by 1 plus x to the power 4 and so on, right? First we have to write the given series in the generalized form. Easily we can write it as given series can be written as summation x to the power n by 1 plus x to the power n, because to represent the alternatively positive and negative terms, we have to include minus 1 to the power n minus 1, n is equal to 1 to infinity, right? Here what is un? In the alternating series, un is the term after sigma minus 1 power n minus 1. So here nth term un is equal to x to the power n by 1 plus x power n, right? It is an alternating series. So to check the nature of the alternating series, only one test is available, which is the Leibniz test. To apply the Leibniz test, it must satisfy the two conditions, then we say that it is convergent. What is the first condition? u1 greater than, u2 greater than, so on greater than, un greater than, un plus 1 and so on, right? So consider un minus un plus 1, which is x to the power n by 1 plus x to the power n minus un plus 1 is x power n plus 1 by 1 plus x power n plus 1. Apply the LCM here. X power n into 1 plus x power n plus 1 minus x to the power n plus 1 into 1 plus x to the power n by 1 plus x power n into 1 plus x power n plus 1. Simplify the numerator. 2n plus 1 minus x power n plus 1, 2n plus 1, 1 plus x power n, 1 plus x power n plus 1. These two terms this and this cancel. Now taking common x to the power n from the numerator, remaining is 1 minus x by 1 plus x to the power n into 1 plus x to the power n plus 1. Now you have both numerator and denominator. If both are positive, otherwise both are negative, then the value is positive. If one is positive, other one is negative, the ratio is negative, right? X to the power n is always positive. Now coming to the denominator, two terms are always positive. X power n is also positive. What about 1 minus x? So this entire ratio depends on 1 minus x. If 1 minus x value is positive, ratio is positive. If 1 minus x value is negative, then ratio is negative, right? So it is positive for 0 less than x less than 1. Because for this 0 less than x less than 1, what about 1 minus x? It is greater than 0. and it is negative for x greater than 1. When x greater than 1, 1 minus x value is less than 0. Whenever 1 minus x is less than 0, entire ratio becomes negative, means less than 0. Therefore, un minus un plus 1 is greater than 0 only when 0 less than x less than 1. What about second condition? Limit n tends to infinity un. Limit n tends to infinity. What is un here? X to the power n by 1 plus x to the power n, which is limit n tends to infinity. We can write it as 1 by 1 plus 1 by x to the power n plus 1. As n tends to infinity and the value of x is lies in between 0 less than x less than 1. In that case, x to the power n, right, tends to, this x to the power n tends to 0. As n tends to infinity and if the value of x lies in between 0 and 1, x to the power n tends to 0. 1 by 0 is infinity. Infinity plus 1 is infinity. 1 by infinity, limit value is 0. Right? So, limit n tends to infinity, un is equal to 0. It is valid only for 0 less than x less than 1. If x value is other than this boundary, as n tends to infinity, x to the power n also tends to infinity, right? Therefore, by Leibniz test, given alternating series sigma n is equal to 1 to infinity minus 1 to the power n minus 1 into x to the power n by 1 plus x power n is convergent when it is convergent for 0 less than x less than 1. If x value is outside this boundary, given series is not convergent, it is divergent, right? Like this, we have to identify the nature of the alternating series, right?